Algebra 1 students, welcome to today's notes. This is section 2.2, solving two-step equations. We're going to start with a reminder from 2.1. We saw this actually in our 2.1 notes, but we're going to look at it one more time just to remind ourselves we need to keep drilling this in. Inverse operations are operations that undo each other. And as we previously talked about, the examples would be addition and subtraction are inverses. Also, multiplication and division are inverses of each other. So in other words, multiplication undoes division and vice versa. Same situation with addition and subtraction. When we use two-step problems, when we solve two-step problems, we always have to go in the reverse order of operations. So order of operations is multiplication, then addition would be what we would think about with this problem, but you have to reverse that. You have to do the addition first. To undo addition, we subtract. 3x equal to 15. Then we can undo our multiplication by dividing. And we'll come up with the solution of x equals 5. In example 2, you can see we have a division and subtraction to deal with. We'll deal with the subtraction first because, again, we're following the reverse order of operations. So we'll add 2 to each side. That will give us x over 4 equals 10. Next, we need to, again, isolate the variable. To make that happen, multiply both sides of your equation by 4. So x would equal 40. All right. Why don't you pause the video and work on these next two. When you're done, hit play and compare answers. All right, welcome back. On number 3, we have to undo the addition first, so we will subtract 6 from each side of our equation. So negative x will equal 3. One thing you have to remember is when we have a negative x, we can't leave our answer that way. We need to actually solve for x. So in order to do that, we have to divide by negative 1. Some of you may be saying, well, where did that negative 1 come from, Mr. Hale? It's the idea that when you see negative x, that's the exact same thing as saying negative 1 times x. We just typically don't write the 1 coefficient before variables. All right, on example number 4, what we looked at here is x plus 5 divided by 3 equals 10. Now in this case, we actually have to deal with the multiplication first, and that may seem a little strange, seeing that we have addition in the numerator of our fraction. However, the fraction bar is a grouping symbol, so when we see that, you have to think of the grouping symbol being the first thing you do in the order of operations. So we actually have to deal with the division first. So here we'll have x plus 5 equals 10 times 3, or just simply 30. Now we're to a problem we're more familiar with. We can subtract 5 from each side, and we'll get x equal to 25. All right. Moving ahead. A couple of application problems for you. The first one says Susie has $26 in a coupon for $2 off at Best Buy. A CD costs $3. How many CDs can she buy? The first thing we need to do in problems like this is to define our variables. So we're going to say x represents right here it says we're looking for how many CDs can she buy. So X is going to represent the number of CDs. Now let's set up our equation to represent the situation. We know CDs cost $3, so $3 times the number of CDs. However, Susie has a $2 coupon, so that's actually subtracting from her expenses. And she has $26 that she can spend, so we'll set that equal to 26. So 3 times the number of CDs minus $2 for the coupon equals the $26 that Susie can spend. So let's go through and solve this equation. We'll add 2 to each side. 3x equals 28. Now I'm going to rewrite that over here as I continue my work. And to undo this multiplication, we need to divide. And this is where it might get a little weird, because you look at it and say, well, 28 divided by 3 does not come out evenly. As a matter of fact, it's 9 1/3. However, most stores don't sell 1/3 of a CD. So what we would have to say is that Susie could buy 9 CDs. That would be the maximum. All right, on number 6, Frank is going bowling. Shoe rental costs $3, and each game costs an additional $2.50. Frank has a total of $12 he can spend. So how many games can he bowl? Well, the first thing to consider is that the shoe rental is a one-time expense. So his expenses are going to be represented by $3 plus. Now I've got to pause for a minute. We haven't defined a variable yet. We need to do that. Well, what are we trying to find out? It's the answer to the question. How many games can he bowl? So let's have our variable be defined as the number of games. We know it costs $2.50 per game, so we can write that here, $2.50 times X. And we know Frank has a total of $12 he could spend. I'm going to solve this equation fairly quickly, as we've gone through a few of these now. So we subtract 3. Then we would divide. And again, we run into the situation of the division not working out evenly. It's 4, but then we have a remainder of 2, so we could do it as 2, and this is a little awkward because it's a fraction and a decimal mixed together. But the reality is, we want to know how many games he can purchase, and he can purchase 4 games. All right, the last thing we're going to look at is essentially an introduction to proof. It says to solve each equation and then justify each step. Now, whenever we do the justification of each step, next to every step we have to have a reason. So when we see the first step, it says 3x minus 7 equals 14. This is our given problem. We don't have to do anything to get to that. It's handed to us. It's given to us. All right, the first thing that we would actually do from here is add 7 to both sides. And that would give us then 3x equals 21. What allows us to add 7 to each side? Well, that's the addition property of equality. The next step to solving this equation is to divide by 3 on both sides. So x equals 7. How did we go from 3x equals 21 to x equals 7? Well, we would divide it by 3, which is the division property of equality. So again, on every step, we have to list a reason. Let's do one more of these. Number 8. The first thing we would need to do to isolate our variable is subtract 4 from each side. So we'll have 7 equals x over 5. Now I've already neglected one thing, and that was I needed to write my reason on the first step. The reason was it was the given problem. How did I go from the given problem to my next step of 7 equals x over 5? I used subtraction. So it's the subtraction property of equality. The last step in this problem to isolate my variable is actually to multiply both sides by 5. So I'll know that 35 is equal to x. How did I get there? We multiplied. So we call that the multiplication property of equality. Now that you've finished on the notes, I want you to look at the link that's just below this video. Click on it and answer the questions that are there. And then when you come to class Monday, we will work on the assignment from this section. Have a great weekend.